Hey, what's going on YouTube? Let's talk about substitute algorithm. A simple technique to add more clarity and yet again more readability to your code. So let's get into it. Now, what is substitute algorithm? Simply put, it's replacing an existing algorithm with one that is more clear. You can do this by replacing the body of the method with a new algorithm. It's that simple. If you find an algorithm that is much simpler and more efficient, then replace the old algorithm with a new one. Don't let the word algorithm scare you. It's simply a set of steps that you follow to achieve a result. So, when you're deciding whether to replace an algorithm, you should ask yourself a few questions. Number one, does the current language have any out-of-the-box solutions, i.e. data structures or helpers you can leverage? Don't reinvent the wheel unless you plan on creating a better wheel. Number two, will there be any major performance issues? Is this algorithm more efficient? For instance, the algorithm might be clearer, but if it causes your application to run slower, then you probably should look at the pros and cons and explore alternate solutions. Now, the implementation of this technique is pretty simple. The first thing you're going to do is run tests against your existing algorithm, note the output, then replace the content of the method with a new algorithm, run tests against the new algorithm, make note of the output, and if the tests are the same, then you're done. If they're not the same, then you have to debug and figure out why the tests differ. And that's it. Remember, the goal here is to reduce complexity and add clarity and readability. Now, let's look at a few small examples. Alright, so we have our class here, Rolodex. Within Rolodex, we have employee list, which is an array that holds some objects that represent our employees. It's just two employees right now, Lehman and Frankie, just to keep it simple. We have a method called find employee by name, which takes a name parameter. The method's going to iterate through employee list and find out at which index that employee sits at. And it's going to return it as Rolodex page. In this case, we're returning it as Rolodex page plus 1, simply because arrays start at 0 and there is no page 0. Right, so we want page 1 here if we find Lehman. So this algorithm is fairly short and simple, but we can make this a lot shorter and a lot more clear. JavaScript has a few methods we can leverage. First thing we're going to do here, we're going to run this, and we can see that it's saying employee listed on page 2. So we're looking for Frankie here, and Frankie is listed on page 2. If you look for Lehman, Lehman's listed on page 1, which is correct. Is that index 0 plus 1, page 1. Alright, so what we want to do here now is, since we ran this and we noted the output, actually let me undo that, look for Frankie again, page 2. Since we ran this and we noted the output, now we want to paste in our new algorithm. Have something prepared ahead of time. Now we're going to run it and note the output. Employee listed on page 2. So we can see that Frankie here is showing up on page 2, which is correct. And if we change this to Lehman, save that, showing up on page 1, which is correct. So our outputs are the same. That means the algorithm replacement worked. Everything is A-OK. Alright, so looking at our new algorithm here, this is a simple one-liner and is a lot more clear. Now what this is doing here is leveraging JavaScript's built-in map method, which operates an array. And essentially this is saying, transform this array to match whatever this callback here using the fat arrow is specifying. So this is saying employee.firstname, which means return just the first name from our objects that we have here. So employee ID and last name will not be returned in array. So we're going to get an array of just first names. Then look at that array and find the index of that name and then increment it or add 1 to it. And let's say this again just for the sake of it. And we can see employee listed on page 1. That's for Lehman. And if we copy Frankie here, Frankie listed on page 2. Alright, so our output of our new algorithm matches the output of our old algorithm, which means we're done. The substitution worked perfectly. Alright, so let's jump to another simple example here. Okay, example number 2 here. Alright, so we have our class here, numProcessor. Within numProcessor, we have numList, which holds a list of numbers. Now we have our method to calculate sum. It's going to iterate through numList, and then it's going to return the sum of this entire array that we have listed up here. So once again, this is pretty short, but we can make this a nice short one-liner by leveraging JavaScript's built-in methods. First thing we want to do here is actually want to run this. I'm going to make note of the output, 235,131. I have it commented out here. And then the next thing we want to do here is we want to replace the existing algorithm with a new algorithm, which is a simple one-liner, similar to our other one. And we're going to run it again and then make note of the output here, 235,131. So it matches the old output. So old output matches new output. That means we're done. Okay, so we have our final solution here, which is a nice simple one-liner, which is a bit more clear than what we had before. And once again, we're leveraging JavaScript's reduce method here. So if we look at the documentation for reduce, it says calls the specified callback function for all elements in an array. The return value of the callback function is the accumulated result and is provided as an argument in the next call to the callback function. So if you look here, the initial arguments will be 123 and 3 in this case, which is 126. And then for the next callback here, this is the callback function that we have. It's going to provide 126 and 4. And it's going to keep doing this for the entirety of the array. And remember, reduce takes a list of multiple values and reduces it down to a single result, which is the sum in this case, right? And our sum here is 235,131, which matches our old value for our old algorithm. I'll stick some links in the description about some of the JavaScript methods I used today. So to summarize here, you want to use substitute algorithm when you have a new algorithm that is either more clear or more efficient than your existing algorithm. And as far as implementation, you want to run tests against your existing algorithm, replace the content of the method, run tests against your new algorithm. If the tests are the same, you're done. If they're not the same, you'll have to do a little bit of debugging to figure out why they're not the same. Alright, so that's going to wrap up our video for today. Remember to like and subscribe, and reach out in the comments and say hi. Peace.